This is the first video for the 7.2b lesson on quadratic functions. We're going to fill out a table for the steel dragon, which they provide us with a function. We're not supposed to build these for problems like this, even by the end of this lesson. That would be for high school. And it is written in function notation, which tells us it is going to be a function. We can also see that it has h, which is the height. I think that was defined on the previous page. Is also stated down here, and t, which is time in seconds. And we can already tell this is not a linear function, not to mention it's titled quadratic functions. And they chose 5 values for us to plug in, and we are going to sketch this graph. I also have a 4 column version of this table where I'm going to do my work. I would suggest doing this on scratch paper. I also want to show this in case this is in the homework as far as how to do this. So this type of table just gives you some workspace. 400 minus 16 times 1 squared is 400 minus 16 times 1, which is going to leave us 384. And then, we don't normally do this last column, but in this case we will. Or in the case of the Desmos one, we'll just enter these in a minute. So you don't necessarily need to fill this out. All right. Then we've got the time 2, which is, and this is important because later in this lesson, we are going to be building tables like we did with absolute value graphs to sketch these as well as predict what's happening. So it's important to remind ourselves that when we're doing this, a common error with quadratic functions is not correctly applying order of operations. It's 2 squared. Technically, really should have parentheses around this, and then multiply by 16, and then deduct that from the 400. So 400 minus 64 leaves us with 336. 2 comma 336. If you feel like you've got it, you can feel free to skip to the end. I'm going to kind of point out a couple other things. We are just kind of doing some number crunching here. 400 minus 16 times 9 will leave us with 256. $144. And the last one, if you're skipping to the end of this video, then you've made it here, and this ends up being 400 minus 400. 16 times 25 is 400, so this is 0. All right. Before we go to the graph and sketch this, we can already kind of analyze this table and also convince ourselves that this is not linear, because we can see that the change in x is remaining constant, but the change in y is not. And so the first difference is not constant. This one down here is easy to see. The change in y is down 144, but the change in y up at the top of the table is 16. So we can see that gravity is acting on this object, as well as it's a roller coaster. So there's probably a lot of other things happening on here, or happening in this scenario or example. But as this object has more time to fall, it's speeding up, and therefore the amount of distance or height that it's covering is getting greater and greater. Now we'll go to the graph and sketch this or fill this out. And this graph is going to have elements that are like absolute value, but we are going to curve this graph. So this was 400, was 384, 336, 256, 144, and 50. So we actually have in this graph the y-intercept, and we also have the x-intercept. Because one of the questions we were supposed to think about is how long would it take the steel dragon to reach the bottom of this drop. And so we're going to try to connect these points. And the way that we do that is we are going to create on these graphs like a U-shaped graph, not a V-shaped graph, but something that's more curved. It almost looks like a smiley face or a frown. And we will see the whole graph once we go to some other examples that are not about time and height. But for now, we're restricting this one in the first quadrant. And notice how I kind of curved it. It's not as sharp as an absolute value graph, but it has some of the same characteristics. And there is our first quadratic that we've sketched. And in a couple of slides, you'll also hear it describe the fact that this curve, this specific graph is called a parabola.